Okay, so hello, welcome to our next BrnoJUG user group session. Today we have Jiří Andrlík speaking about JDK26. So please enjoy.
Okay, so welcome everyone. My name is Jiří Andrlík. I'm software engineer at IBM in the OpenJDK QA team. And I'm here to talk about JDK26, as you just heard. So let's dive into it. So OpenJDK26 features 10 JEPs, which I personally grouped by, grouped into groups. You might not agree with my grouping. This presentation similarly to the other example. And again, I'm just using reflection to change the 10 to 42. Interesting thing might be, well, 6 warnings. I can't read this big text. Yeah, it should be all right. So up and running it, we get the same warning, and number 42, which is read by reflection. In the previous example, the interesting thing is that if you access the variable directly, it still reads 10, but by the reflection it says 42. So that's about it. Yeah, there are new arguments for this JEP. They are illegal final field mutation, which are global. With this argument, you can allow more debug or deny the modification, and with enable final field mutation, you can basically turn it on and off for individual modules. Or the all unnamed is a keyword for all the unnamed modules, because not every time you have a module. So That's the JEP 500. Does anyone have any questions to this one? Okay. So next one, removing the Applet API. Yeah, so Applet API has been with us for this year. It will be 30 years. And as a married man who has a 30-year-old wife, I have to say that it's a fairly new feature, fairly fresh. Yeah, but with JDK26 this ends, and the Applet API is no longer available. Even if you compile the code with older JDK, then you can't really run it with JDK26. So if you are dependent on Applet API, well, bad luck. That's it for this JEP. Anyone? Anything? Okay. This will be a short presentation.
Have you used Applet?
Well, in my early days as an intern, I was forced to manually check applets as part of my job to make sure that individual applets still work with current Java implementation. So there was a time when I was paid for an hour to browse through online games and make sure that they still work.
Oh, really? Half of the OpenJDK team career was based on the implementation of the applets.
Yeah, it drove a lot of careers. I'm not going to name anyone, but I know at least 4 people whose career was driven or like started with Applet implementation. Yeah. So, okay. So next one is exciting because Java finally has native support for HTTP3 in HTTP client. What it does, well, it's newer and better in basically any way. HTTP3 is better than HTTP2, especially on high latencies networks, and it just increases the speed of your connection. Well, I have a benchmark later. And up until now, we only have HTTP3 with the help of external libraries, namely Quick or Jetty HTTP client. So HTTP3 introduces Quick as opposed to TCP. Quick is based on UDP, and well, this change basically drives all the improvements that there are, almost all. I just want to play it on the side so I don't get angry emails from OpenJDK developers later. So I don't want to say that it's the only thing. Yeah. So it used to be the case that a loss of a packet blocked all streams. That's no longer the case. Handshake shortened from 2 to 3 round trips to at most 1. There is a special case where it can be 0 0 round trips, but don't make me explain it because I didn't really understand it that well. Another nice thing is that connection is tied to an ID as opposed to IP. So if you switch networks, then your connection no longer like resets or needs to re-establish, which is potentially huge for mobile users when you switch Wi-Fi's or from mobile network to Wi-Fi or anything like that. And lastly, the TLS13 is built in, so that's a built-in security into HTTP3. So what does it really mean in benchmark? I have a really simple benchmark which I used on a high latency network. It was with my wife's grandma where we had really bad connection. So these are the numbers that I achieved. So it halved, virtually halved all of them, especially the average response time. Yeah, so it's about this probably. Yeah. But it only features this improvement with HTTP capable servers. So it doesn't really apply to everything, only with the servers that already support HTTP3. So that's our third JEP. Anyone have any questions? No? Okay. Yeah. Structured concurrency. My least favorite one because I spent most time on it. Yeah, I always hated how concurrency is written in Java and basically any other language since my time on university when we had to write some concurrent code. Structured concurrency should simplify it a great deal. And basically handle a lot of corner cases for you, especially like the thread management and exceptions. It groups the threads into scopes, which is basically how it works. Yeah, the exceptions are handling unifiedly, and well, the structured concurrency is not a first preview. So what's actually new since, well, oh, this is an empty slide. Okay, I wasn't probably able to, oh, I just didn't add it to the presentation. Yeah, there was, I think like 2 renames of methods since OpenJDK25. Sorry that I didn't include it in the presentation. Happens, no? Yeah, and Open used to take an argument of a function. Now it takes unary operator, so it basically widened the scope of the arguments. And there's a new onTimeout method in joiner interface that lets you handle timeouts. Like you can write a custom timeout handling, and in theory you could write your own handling and get partial results, which is not otherwise allowed with structured concurrency. Sadly, I wasn't able to make a demo about the onTimeout method because it proved to be too complicated given the time I had. So yeah, we can take a look at the code. Yeah. So, well, we can do side-by-side comparison probably. No. Detach. Yeah. So on the left side we have the new structured concurrency code. These codes basically do exactly the same thing, except the one on the left works with scopes, whereas the one on the right uses traditional handling. I'm probably not going into detail of how it works. I don't know, the code is visually more pleasing and you don't have to make that much handling with exceptions. Yeah. Any questions to this JEP. I can run the code, so you don't have to take my word for it being able to run. So this is the traditional code, which executes both of the threads. And this is the new code, exactly the same result. So any questions?
Can you show the code side by side again?
Yeah, sure.
Where is the exception gone?
Where is the what?
The exception.
What exception?
The interrupt is
It is a.
on the left side.
There is not. It propagates outside.
That's the question. Where it's gone?
Well, I let it propagate outside. Okay. Yeah. Yeah, I forgot the catch statement.
No, you are not catching it. You are throwing it away.
Yep. You're right.
Okay.
So it's not exactly the same code, and yeah, that's my boss basically who was speaking, and I already hate him. So let's move on. Yeah, primitive types. Oh, sorry, we had another question.
Just a question: why are you actually compiling with Java C first? Don't you like directly run Java, whatever that Java? Is there a reason for that?
Well, I did some. Well, when I prepared the demos, I had to make a lot of comparisons between JDK25 and 26 because I was trying to find out what is actually new in JDK26. So I was constantly switching among those two. And when I started to prepare the demos, I was too lazy to, yeah. I just copy-pasted all the comments, and I know I should have. I know it's not visually pleasing, and yeah, you can scold me later.
That's not what I mean. I mean, why are you running Java C first and not directly Java?
Oh yeah, just so you know that the code actually compiles. That I am not trying to impose a code that's not actually running.
That's not the reason. The compilation warnings are different. That's the reason. You have to explain it.
What?
The compilation warnings are different.
Yes, sometimes, but
Always.
yeah. So primitive types in patterns and pattern matching. So this one is more or less about Java being consistent, because we used to have, the Java used to not be able to match patterns, for example, of primitives, the int and etc. So this is an attempt to make Java consistent. You don't have to box anything anymore. You don't have to, or there's a nice feature that helps you, that enables you to match the pattern and assign a variable to with a new name at the same time, and it works with switch as well. So yeah, and I have a demo about it as well, which I'm gonna be scolded again for. Yeah, it looks much nicer when it's not, when the terminal is not this enlarged. Yeah, so These are the two approaches. This is the new primitive time pattern. As you can see, I can do instance of at the same time as casting the new the variable to casting the value to a new variable. So this basically means is the value instance of int, and if it is, then cast it to int and assign it to I. We were not able to do that before. So this is the old approach, where we have to first make sure that it's integer and not int, and then cast it to integer and only then print it or do whatever we want with it. And it also, the primitive matching also works with switch case. Yeah, so, but this is not a new feature as well. This is already fourth preview, but since last time there are not that many changes. The main one would be probably the domination check, which applies mainly to the switch case. So when I add this line to it, then the switch case on compilation will realize that the byte part will not ever be reached, and it will stop the compilation. So, yep. Yeah, let's run. And this time I really have to compile it again, so that we can see that it presented an error. It is advertised that this feature is new to JDK26, but I tested JDK25 and it was there as well. So it's very hard to hit corner cases with the corner cases that were not able to be written in JDK25 and are caught in JDK26. That sentence didn't make sense, but I think you know what I wanted to say. Yeah. So back to demo. It works. Yay.
If you switch the lines, the int and byte, then it will work as the hope.
It should. I'm not really in a position to guarantee it at this moment, because I really did a lot of trial and error with this JEP, and I believe this one didn't work actually. Yeah, this one is not supposed to work like this, because the byte only goes to 128, so we would have to lower this number a bit. Yeah, there's a distinction.
Oh, put the number back.
What?
Put the number back.
Well, let's test first this thing, and then I'll put the number back. Yeah, it recognizes as an int as well, so it skips the byte for some reason. In the JEP, it is said that this should work, and it should really hit the byte thing. I'm not really sure what I'm doing wrong here, but...
Try to cast it to this line.
Well, I can definitely try it. But first, let's try refinements proposition. It's as expected.
Put 300 there.
Yeah, on this line.
Well, what are you expecting to change when there is 300?
Cast it to the byte as is.
Yeah, cast it to byte because everything is default. By default is integer.
Exactly.
No. When you are casting like object O equals brackets byte.
So we want to cast it here.
No.
What?
It lets you replicate.
At the declaration.
At the declaration.
Yeah. Here.
We also have to lower the value.
Oh yeah. All right. I'm distracted. See. It's still, yeah, it's byte. Nice. Interesting question from me would be, if I disable this line, will it hit in? No. Interesting.
No logic.
But the JEP tells that the conversion should be direct and lossless, so I don't know. Well, any other questions to this job?
I have maybe a little bit different question, like if the preview is actually like iterated, like this for preview, does the JEP needs to provide new features, or can it be like the same as the?
Well, not always. I think one of the JEPs said that it's only an iteration that, that there are no new features or modifications. I'm not sure which one it was at this time. But it's not a guarantee that there was not a minor change inside. So you would have to see for yourself inside the native Java code. Yeah. So PEM encodings. I did a talk about PEM encodings last time. I was in BjUG, sorry. So firstly, what is PEM? PEM is this ugly piece of code that you see here with a typo in it that I made on purpose. It was to test something and I forgot that it's there, and then took a screenshot and forgot about it. Yeah, so PEMs are these kind of structures that store the different certificates, private keys, public keys, etc. And Java tries to have native unified support for them. It mainly handles strings and string conversion to PEMs and vice versa. So, yeah. And since last time, this JEP should provide a more tolerant implementation of PEM. What PEM stands for is, privacy enhanced mail. Let's forget that one. And there are some minor improvements and tweaks since last time, but and it should introduce better real-life scenarios. I think I found a little issue with it myself, but I'm not sure whether it's an issue. I would have to discuss it with dev. We can see it in the demo. So which one was it? 524. Yeah. It was not able to process key pairs last time I was presenting it, and it should be able now. So we have a code here that generates a key pair, then it stores it as encrypted, but that doesn't really bother us that much. And yeah, this part is where I was a bit lost. Wow. No. pair. Oh. Oh yeah, you're right. Yeah, cool. And the other one, I'll try to show exactly the issue that I encountered. It's this, that basically I generated a key pair and it gave me single PAM structure. Whereas when I generate, well, when I only take, and it claims that it's private key only, right? And, well, maybe it is correct when I think about it again. Wow, sorry. I'm just curious about what happens, because when I get private, then it definitely prints private, right? But I think it should have printed both structures, and I'm just curious about this, whether the structures will, well, whether the key private, well, the private key will be the same, or whether there is some nasty things happening inside of it. So. This should work. Yeah, this is strange because the first time, if you look at the code, the first time it's still the same key pair, the original, which is stored here. And first time I want only the private keys to encode as PAM, and the other time I want the whole, no, I send the whole key pair to the PAM encoder. But as you can see, if like looking only at the two last characters, they are not the same. It's not the same key, but it in both cases it just claims that there is an encoded private key inside of it. So that might be something worth looking into. But I'm not sure. Maybe. What do you think, Jiří? I can see your expression.
I'm just wondering, because the typical side is just padding, so something and the head, it looks like the same thing.
It's not the same thing because the hash is different. And it's
the first line is equal.
Which line? This
First
one?
line. That's all I have. I wasn't able to read faster, sorry.
Yeah, but the last one is different. So that's the question, you know. And it says that this is encoded private key, and this is also encoded private key, the same private key. You know what I'm trying to say, right? Well, yeah. So yeah. This is the demo about PAM. I think I had another demo, but it's basically the same, but no, it's not the same. This demo shows how decoding works. So I have a public key here. I'll explain why I did the typo here later. And I'll make it again, don't worry. Yeah, so this is hard-coded public key. Why hard-coded? Well, it doesn't really matter because the decoder accepts string, so if I stored it in a separate object, I would still have to read it somehow, so it's really easier this way. Yeah, and here is the code for decoding it. I don't know what to say about it. Just a bunch of built-in functions that I've called. You can go through it later yourself, I guess. Yeah, but one interesting thing about this is I have to redo it. Or it is interesting for me, it might not be interesting for you, right? So this time it detects its public key. At the end of the demo, there is a switch case that that detects whether I am entering public key, key pair, PEM, or anything else. How does it know? That's what I wanted to know. And it's basically the header and the footer. Nothing else is done here. So if I make a typo here, that it's public and not public, then suddenly the switch case does the, well, it basically triggers the default switch case at the end, because it didn't recognize the header and the footer. So the header and the footer of the PEM are what drives this. Yeah. That was interesting for me, but it might not be for you. Any questions for this PEM?
There isn't like something like verify or something, no, like to actually check this, you need to do the manual verification?
There actually is. If I change the value of the key itself, it verifies that it is a wrong key. I don't know. I have a low chance on modifying it in a way that it would end up being a legit thing. So yeah.
Don't you think that this is maybe a bug?
Not enough, very big bit. So?
Maybe this is a bug. Maybe you should call this.
Which one?
Well,
maybe I can try, but maybe that is supposed default behavior, because you don't want to like erroring it all the time or failing all the time. If it doesn't recognize the structure, it should allow it for some reason. Maybe I don't know. Because somebody can have their own PEM structures, their custom PEM structures, maybe. I don't know. Yeah. So no questions, I guess. No more questions. Yeah. Another demo is lazy constants. This is the second preview. And last time we were not able to measure anything or showcase much on this demo, but the demo has been heavily reworked. Last time I believe it was called stable values. So they redid the name and they also redid most of the implementation as far as I'm concerned, or at least it looks very different. What it does, it improves startup time. It is very useful when you have a library or a code that has a lot of constants and you don't need all of them every time, but you want your code to start up fast. So yeah, 5 to 6. And the other one as well. So, this is how a lazy constant looks like. This is how it's defined. And to measure it, I set it to a value of a heavy compute, which does like 200 million computations before it assigns anything to it. And I compare it to classical final values, which are instantiated at the start of the program. So this is It's virtually a really simple benchmark, this thing. Yeah, and the important thing that I forgot to mention is that I don't actually in the main here access the final values anywhere, but I only access the two lazy final values. So just keep that in mind. Yeah, so it takes the lazy values to initialize 7 milliseconds, and the eager final, or the classical old final, for 542 milliseconds. So it initializes all of them, whereas the lazy finals are only initialized when accessed. And since I only wanted 2 of them out of total 10, and there are 10 constants as well in the old final, then it makes sense that it does like 1/5 of the work. So, yep. That's it for final values. And I also tried to measure it from other perspective to try and ask for all of the constant, the lazy constant values, and it proved to be a bit quicker than the old lazy init, but not by much. And well, since it was not really, I don't think it was the intention of this JEP, and I can't really prove that there is that much of an improvement, but it's definitely not slower than old final approach. Any questions to this one?
Is there a plan, or is it possible already to set a parameter on JVM to basically do also static final as it would be lazy?
I'm not aware of anything like that, no. But it would be nice, wouldn't it? Yeah. So another one, and I didn't like this one either. Yeah, about this one has been thoroughly presented by my colleague Karm last time on JDK25. And if you have any questions or are interested in it, please watch his presentation, because he went much deeper than I did, and he is very knowledgeable about this. Yeah, so it was first introduced in JEP 483, sorry, in JDK24. And it's another refinement, and the main difference is that it now should work with any GC implementation. Why it didn't work with any GC implementation before is because it used physical links to heap memory, and they basically did 2 implementations. One is the old one, where it still uses the old approach of physical addresses, and the other one, the new one, is with relative addresses inside the heap memory, which is now compatible with any GC. And the JVM, upon creating the AOT cache, basically makes an informative decision which approach to use. So it costs a little bit, but really the improvements in the JDK26 are that great that it really didn't make any difference. As you can see in the graph, when I used no AOT, and in JDK25 and 26, then it still increased in performance. And the performance by starting with AOT cache was quite dramatic. And yeah, so how I did the benchmark for this, you might ask. I did a very dumb thing. I created 10,000 class, 10,000 classes. No. That's not it. Oh, 16. Yeah. I'm not going to show all of them. Oh, 20,000. Oh no, it's 10,000 class files and 10,000 Java files. So yeah. So I created 10,000 classes, and main should just load all of them. Yeah. It loads all of the classes out of those 10,000, and that's basically how I was able to measure the difference between the two. There were other naive approaches that I tried, but the class loading is basically the main difference for AOT. What AOT does is it basically creates this cache where it stores pre-initialized classes for Java, so it doesn't really have to go and fetch everything again from the memory. The good thing to say about it is that the cache can be quite large. When you do hello world, it can go up as high as to 10 megabytes, and it's just hello world. So it can be really large. But it is beneficial if you want your app to start really fast. So yeah, I'm not going to show the demo for this, but I'll provide the files so you can try it at home.
You have several questions.
When
you are creating the ahead of time thing, you are specifying the garbage collector?
Yeah, I am. Actually, the garbage collector that made the most difference, or that this was mainly made for, was the GC, because the GC didn't have the support. Well, it didn't have support for the GC. But as you can see in the graph, you can generate the cache in JDK25 as well for the AOT, and it still makes a difference, but not as huge as the one in JDK26.
When you use different garbage collectors, is the size of the binary different?
I didn't really think to check the size among different garbage collectors. I just know that you can't generate the cache with one garbage collector and run it with another one and expect it to work. But it will fail silently, which is interesting. It will just not tell you that it doesn't use the cache. It will just run, but slowly, as if there was no cache, which is basically how it behaves. And question didn't back.
So this is normal project latent, so I suppose that cache you need to create manually as a first run, and then you will pass the AOT file to
Exactly.
BrnoJUG. What happens if you use diff and GC for the training run and in the real JDK?
I just said it, but maybe not loud enough. It basically behaves as if you had no cache, but it doesn't tell you.
If you enable the log for AOT, it will tell you. At least when I was playing with it, with the different Java, but like if it fails load the cache, it will tell you. It
didn't tell me actually.
I need to specify like dash x log or something like this.
Well, I consulted this one with Karm, and he said there's a magical argument that he's not able to produce at the moment that tells you whether the cache was used or not. and it fails if the cache was not used. So this might be it, like the thing that you are talking about. This might be what he told me about. I didn't really hunt it down.
One more question.
Oh no.
Do you know if the garbage collectors were modified, or if the modification was outside to be able to work with the other garbage collectors?
It should be a modification inside of the AOT approach, because as I said earlier, the AOT used to give physical addresses or link physical addresses of the objects in the heap to well, it stored these addresses into the cache, and right now it's using relative addresses.
So any new garbage collector added in the meantime?
It should be. Yeah. The purpose of this JEP was to not divide, separate the implementation of AOT from that of a garbage collector. So it should not be dependent anymore. Yeah. Okay, sorry. Another JEP is about G1 GC, garbage collector G1, and supposedly it had a lot of synchronization, and that synchronization was a bottleneck. There was a lot of locking happening inside of G1. So what it does now, it's supposed to do a local synchronization between the objects and then occasionally merge it. Honestly, I was not, oh, there's two settings still. I was not able to reproduce it. I did few benchmarks with a lot of objects creation and a limited heap space, and only in like 2 out of my 8 attempts I was able to make something out of it and have better results in JDK26 than JDK25. And still the improvement was not that significant, considering that it was not reliable at all. Yeah.
But one of the purposes of this JEP was to simplify actually the whole G1 code, right?
Yeah, exactly, as well. Simplified and well, reduction of synchronization would imply that there would be better performance of the garbage collector. I was not able to measure it.
7%.
What?
7%.
Well, yeah, but only in 2 out of 10 or 8 attempts. So I'm just being honest here. Yeah. And yeah, any questions about this one? Anyone interested in garbage collectors? Please don't. Okay. And lastly, there is JEP 5219, the vector API, which is quite long with us. It's since JDK 17 or 16. Well, the number 11 would imply that it's from 15. What is the purpose of this JEP is that it utilizes vector computational capabilities of certain CPUs. For now, it's only for certain ARM and x86 CPUs. For x86 CPUs, you can know this by having flags AVX or AVX2 on the CPU, but basically it should work for any CPU after the year, I don't know, 2016 or so. So if you try it at home, it should be safe, hopefully. and it greatly increases vector computing performance. A good thing to say about this JEP is that JIT actually vectorizes as well in the background. So in order to get such good results and in measurement, I had to suppress the JIT native behavior by this thing. And when we look in the graph where I did not suppress the JEP, there is still some difference, but not as much of a difference. And also it mainly works or is measurable in 10 to the power of 7 and higher long vectors or number of values in vectors. So it can be quite beneficial if you code an engine in Java. It really depends on your use case. So keep that in mind. Any questions to this, Jeff? No?
Any source code around?
You want to see source code for the Vector API benchmark? No. Oh. Here it is. Yeah. So this is 10 to the number of 7, if I read correctly. Yeah, so what it does, this is one of the first JEPs I did, basically, so you have to give me a second if you want me to explain anything. Yeah, this is a built-in value, the species preferred, but otherwise you can specify it yourself, and it should be about number of values that you put inside at the same time, if I remember correctly. Yeah, here you can see all the operations that I do on the vectors to make such a huge difference. So there are 13 operations right now. I also did some experiments whether inlining all the scalar operands would make any difference. It does not. And yeah, so what it basically does is that the processor with the capabilities of vectorization can still only compute a certain number of values at the same time, which should be the species preferred. And so basically it takes the vector, the large vector, and it slices it into parts that are at most exactly X species long. After that, there needs to be some additional computation, because if your vector does have not a length equal to multiple of the preferred species value, then you have to do some additional computation to account for that. So that's this tail. It basically gets last 4 values in the vector and finishes them by hand. Which is quite a good question that just occurred to me, that what if you have vectors shorter than preferred species, but you should be fine by then? Yeah, you should be fine. But you have to specify it. And in this loop I only specified the species. Yeah, so this is the code for it. Yep.
Is it actually right to do the warm-up in this kind of like?
Sorry, you have to speak up.
Is it correct to do warm-up in this kind of scenario? Because I suppose that the vector should be like this performant out of the box.
should be, definitely, but it's a good practice to have warm-up with any benchmark you do.
In this case, the warm-up is here because of the first operation about the arrays. They need to be JITted.
Yep.
And the JIT does pretty well, actually.
So there you have your answer. So any more questions to this JEP?
Show the numbers again. How is it done for you? I mean the result.
Yeah. This is the JIT suppressed option. This is the number of the operations that I did on the numbers, so it increases with more operations.
And the JIT enabled? Tady go to the source code again. Can we do more down?
More down.
Here that species, what was the species? That was the original vector.
What about the original vector?
The species, the definition.
No, the species is the final of to my understanding, this should basically be a number. A number of preferred values of a vector that the processor can evaluate at once or calculate at once.
Okay.
Well, in a single operation.
I don't know.
No, it's not true. It's a smaller vector that is the length of the preferred length. It's not a number, just number. It's length of a vector, and yeah, it's just a final reference to it, and then you change the vector each round it goes around. Yeah. So. Any more questions? Okay, so that's it by me. Those were the 10 JEPs in JDK26.